Hopefully I'm just going to go over the basics of conic sections. It might be a little bit confusing, but we'll go into much greater detail. Conic sections, we're going to go over the 4 conic sections. They're special types of quadratics. All right, so you're aware of the first type, parabolas. Y is equal to x squared. And if it's a negative parabola, if it's y is equal to negative x squared, it will just be a downward facing. Well, the new conic section you need to be introduced to is when x is equal to y squared. And if you think about it, when y is equal to x squared, the parabola is facing upward towards the y-axis. So when x is equal to y squared, the parabola will be facing sideways towards the x-axis. When it's a positive y squared, it faces in the positive direction. When it's negative y squared, it faces in the negative direction. And when it's just x squared or y squared, the vertex is always at the origin. All right, the next conic section is circles. These are kind of the easiest conic section. X squared plus y squared is equal to r squared, where r is the radius. So if you take the square root of that r squared, that tells you how far to go up, down, to the left, and to the right, and then you can draw your circle. Okay, so the circle formula is x squared plus y squared is equal to r squared. The next type of parabola is an ellipse, and its formula is x squared over a squared plus y squared over b squared is equal to 1. Not r squared, but is equal to 1. And when the a, I should say it this way, when the a is larger than the b, it will be a horizontal ellipse. When the b is larger than the a, it'll be a vertical ellipse. So an ellipse may look something like this, or it may look something like this. The last type of conic section is called a hyperbola. And it's the only one, it's the only conic section where you're going to notice a subtract sign. When x squared over a squared subtract y squared over b squared, the hyperbola's curves will be facing towards the x-axis. And when it's y squared is positive and the x squared is negative, the parabola will be facing, or the hyperbola will be facing towards the y-axis, just like that. All right. So here we have a y is equal to negative x squared, and there's no reason to shift it. It'll be an upside down parabola. If you had to tell me the origin would be at 0, 0. Or in this case, not origin, the vertex. Here, everything's been shifted. The opposite of positive 3 is negative 3. On the outside, this tells us to go up or down. We've been practicing the parent graphs. So negative 3, negative 6 is the vertex. And the number on the outside of the parentheses tells us that it's going to be stretched or twice as steep. So at negative 3, negative 6, and it would be a steeper parabola. Okay, and then the sideways ones, x is equal to y squared. This just ends up being a 90-degree parabola from y is equal to x squared. Its vertex is still at 0, 0. For the vertex of this one, what's the opposite of positive 6? So remember, now the y value is inside the parentheses. So when you say the opposite of 5, that's going to be the y value. And then you look on the outside, 6. So we're going to go positive 6, down 5. Let's see, down 5. And because there's this negative sign right here, it's facing the negative direction, and it's going to be 3 times as narrow because the slope is 3. So it will be a more narrow parabola looking something like that. All right. For circles, you have to identify the center and the radius. So for the radius, you just look at the r squared and take the square root of it. So r is equal to 3. The center, since it doesn't give us a reason to shift, is just 0, 0. Then you go over 3, up 3, over 3, down 3, and boom, you can draw circle. Over here, things have been shifted. The opposite of 2 on the x-axis would be -2. The opposite of -3 is +3. The square root of 25 is 5. So at -2, +3, you're going to go 5 over 5 in all directions, and you're going to draw your circle. And the square root of 25 is 5, so there's a radius. All right. For the ellipses, so remember, a circle is a special type of ellipse, but for the true ellipses, this is, remember, is a squared. This is b squared. The square root of 36 is 6. That's how far we go over left and right from wherever the center is. This one, in the numerator, you have x squared and y squared. It's not being shifted, so we know the center is at the origin. The a squared, the square root of a squared is 6, so we go left and right 6. The square root of 9 is 3. We go up and down 3. And then we just... Oh, and I rotated that. Sorry about that. And you just draw your ellipse. If that had been 9 and that would have been 36, whoops, it would have looked like this. All right. On this one, the center was at 0, 0. Need to, and when we're talking about the vertices for the ellipse, typically they just want to know on the major axis, since this is longer horizontally, we want to know these vertices right here on the major axis. So -6, 0 and +6, 0. On this one right here, there's an invisible 1. The square root of 16 is 4, the square root of 1. So we have to locate the center. So the opposite of the x value, the opposite of 3 is -3. And inside the parentheses with the y, the opposite of 6 is -6. So at -3, down here at -6, and then in the x direction, the square root of 16 is 4. We're going to go over 4 in both directions. And the square root of 1 is 1. We're going to go up 1 and down 1. And then you're just going to, and I rotated that one again. It's going to look just like that. And then you're going to have to remember to name those vertices. All right. For the hyperbola, remember the hyperbola is going to look like this if it's y squared minus x squared. And if it's x squared minus y squared, it's going to look like this. All right, so let's get back. So notice we have an x squared minus y squared, and there's nothing with the x's and y's to shift it, so the center will be at 0, 0. And then we do the same thing like the ellipse. We take the square root of 25, which is 5. So we're going to go left and right 5, which means the vertices there are -5, 0 and +5, 0. But on the hyperbola, we need to name the others because remember we have to draw that invisible rectangle. So the square root of 9 is 3, so we're going to go up 3 and down 3, and then we can draw there you go. And the reason that you draw the rectangle and then you draw, let me do this. I'll change colors. You draw the invisible diagonals through the rectangle. It provides boundaries so that when we know that because it's x squared minus y squared, the hyperbola will be facing towards the x-axis. And then you do have to name, so in this case, because we're at the origin, we went down 3 and we went up 3. And on this one and the next couple, I'm just going to, so normally, so look at the a squared and the b squared, they're the same. That means it's going to be a square. And we know it's going to be facing left and right because it's x squared minus y squared. And so if I were to just draw it like that, that's if it were x squared minus y squared with no shifts. We now have to look, what's the opposite of -1? +1. So I'm going to shift this whole thing over 1. But we didn't have to go up or down because there's nothing that causes the y value to shift up or down. So the center will be at 1, 0. And because we're opening left and right, our main vertices are here. So let's see, that's -1, 0 and +3, 0. And we just had to go up 2, down 2, but we shifted over 1 on the x-axis. So 1, -2, 1, +2. And then I'm not going to go over this too much. You're going to do the exact same thing, but when it's y squared minus x squared, and then you'll have to find where so up 1, down 1.5. That graph is going to look something like that. You find the centers, you find the vertices. So here, 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 and here, 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 and here. And you label all the pieces. All right, that's it.